Hi everyone. I hope you all are doing great. So let's wait for 2-3 minutes so that everybody can join. I know it's already we are running a little late, but let everyone can join. Then we will start. So yeah. Okay. So all my dear builders and partners at BRB, I am Diksha. I welcome you all. It's a pleasure to welcome you all in this highly anticipated introductory session of BRB Online. So, also, I extend my heartily welcome to our very special partner for our today's event, Aragon. So, we all know that BRB is basically a billion reasons to build. It is an initiative by Push Protocol. It's a collaboration with the best Web3 protocols in the space. So, have you got the chance to solve some of the hardest problems and win the bounties? Also, a good winning prize. So, yeah, let's welcome our today's guest, Aaron. And I don't think he actually needs an introduction because what I know about himself, about him, like, eat, sleep, DAO, repeat kind of. So, yeah, but yeah, welcome, Aaron. He's a DevRel lead at Aragon. I really found this is amazing. Like the Aaron is working. He's a DAO person. You can communicate. You can ask whatever you have doubts regarding DAO. Everybody's here is very excited for this session. So yeah, I will now hand over my mic to Aaron so that he can continue. Yeah.
Thank you. Highly appreciated. Okay, so my name's Aaron. I'm a developer advocate at Aragon, and as most of you probably know, we're a DAO platform where you can build custom DAOs and governance solutions essentially. So yeah, do you want to show my slides?
Yeah, so guys, we are going to have a very amazing workshop by Aaron. So let us begin. Yeah, you can now present,
Cool.
Aaron.
Thank you very much. Okay, so what we're going to do today is we're going to speed run our way through building a plugin for Aragon. So at the beginning right now, we're just going to cover what Aragon is, how does it work under the hood really briefly, and then we're going to get into some live coding. There's quite a lot of a lot of ground to cover, so I'm going to move pretty fast. But there's a Notion document that goes along with this workshop, and there's also a GitHub repo that's broken down into chapters of where we are. So if you have any questions, just drop them in the chat. And at the end of each section, I'm gonna check the comments and try to address what we can. But we have to move quick, so we've got a lot to go. We've got a lot to cover. So okay, so what is Aragon? How does it work under the hood? So essentially, Aragon is a DAO framework that enables us to create and manage on-chain organizations. I think most of us knows what DAOs are and what they mean, but our new OS6 protocol, it's a bit different to the old one. It's a lot more simplified, streamlined, and it's really amazing. So as a DAO framework, what can you do? So you can create organizations. There's different types of organizations you can have. You can have membership organizations, multi-sigs. You can have dual governance stuff. But essentially, all of these behaviors, they are all pretty much done through plugins, right? So you have you can have a plugin for membership, a plugin to manage your assets, and so on and so forth. Yeah, so this pretty much just shows how the Aragon contracts are pretty much structured. You have a DAO contract that essentially holds all the DAO's assets. It also manages the permissions as well, and yeah, it's very limited in scope. Everything, all the other behaviors like voting, maybe interacting with a DeFi protocol, these are all done through plugins, right? So what are plugins? Plugins can be treasury actions. So you could say, you can make a plugin to do some streaming, or you can have a plugin that does a specific type of governance mechanism, like token weighted voting, or multi-sig signer, or something like that, or anything else really that tells the DAO to do something specifically on chain. There are two parts of the plugin. So you have the plugin itself, which is a contract that has some permissions assigned to it and from it. And there's also the plugin setup contract. This is, you can think of this like the install script for how to install a plugin into a DAO. The life cycle, it goes, you build and then deploy the plugin. You publish the plugin to an on-chain repository, kind of like a on-chain NPM. So your DAO can, it's like a package manager for your DAO, so you can find plugins and install them in. You install the plugin and you use the plugin. Okay, so it's demo time. Before we start, I'm gonna I know I covered that really quickly. I'm gonna check if there are any comments. If there are, just drop them in the chat. Okay, cool. So this will drop me straight into my VS Code instance, but there is a repo for this. Can someone put it in the chat? We'll have it in the links to the video afterwards. If you give me one moment, we will move ahead. Okay. I see both my screens are sharing. Cool. Okay, that's a bit unfortunate. I don't think that should be happening. But anyway, so first thing we want to do is we just want to clone and the repository. When you start, there's going to be a bunch of different branches in the GitHub. You can just go to start here, and that's where you start. So first thing we want to do is, in fact, we want to look at the repo, see what we have here. There's going to be some demo plugins here. There's one called My Plugin. It's the absolute bare minimum of what a plugin can do. It has some permission here. It has an initialize function, and it basically stores a number. This permission, this is how we protect other functions within plugins, and it's basically uses role-based access control. So you may be familiar with this if you use OpenZeppelin role-based access controls. It's pretty similar. We just declare a constant hash some value here, and then we can use that to guard against our different functions, right? So in this, it's to call this store number, you have to have the store permission ID, and then we'll cover how you can assign those later when we do the setup contract. There's also the plugin setup here. We'll cover this again in a bit more detail as we start to get into that section. There's also some tests here. We're using Foundry. If you guys haven't used Foundry before, definitely go check out the docs. There's going to be links in the Notion document. But Foundry allows you to do unit testing, fuzz testing. It's all in Solidity, so you're not context switching between JavaScript and your actual plugin. So there's less abstractions. So I really like Foundry. Yeah. The way these are structured is that you have an abstract contract that sets up your tests, and then each contract after that is a describe block-in if you was using Jest or something like that, and you just run tests with those essentially. So okay, so what are we going to do first? What are we actually building first of all? We're going to build a ERC 4626 vault. So ERC 4626 is a tokenized vault standard. It allows users to pool funds together. it started, I think Yearn were the first people to use tokenized vaults, but now it's like a standard. And what we're going to do is we're going to build a plugin that that allows people to pool funds, but instead of the funds being inside the vault contract, the funds are going to go to the DAO, so the DAO can govern these funds as it wishes, right? So you could think of using this for something like a charity, or maybe like a fund, or something else, right? But it's like a cool primitive, and we're going to like build a plugin with it today. So what is the first thing we're going to do? We are going to go to my Notion documents, and we're going to forge install and pnpm install. So yeah, so we're going to forge install, pnpm install, and I've already used this before, so it actually didn't install the stuff, it just removed some stuff. But yeah, your pnpm install and everything will be there. And we also need to create a new plugin. So let's do that. We'll call this vault plugin.sol. And yeah, so this is pretty much very similar to what you saw with my plugin. It's like the bare bones plugin contract that's there. This is giving you, so this gives you access to some other things inside the plugin base contract, like the DAO and all of these type of things, but we don't have to worry about too much of that for now. We also want to bring in ERC 4626. So let's do that. So all I've done now is I've just got ERC 4626 from Open Zeppelin contracts. In our initialize function, we also need to initialize the ERC 4626 vault and pass it in a token address, which is going to be the base asset for our vault. This could be DAI, USDC, or whatever. Yeah, so what do we want to do next? Okay, so we want to override some functions of this ERC 4626 vault. We want to keep most of it the same, but what the default behavior of these vaults is that when you deposit funds into the vault, those funds stay in the vault, and then you may have some strategy contracts that does something with them, but we don't want to do that. We want these funds to go directly from the user who's interacting with the vault into the DAO. And we also want, when the user wants to withdraw their funds, to take those funds from the DAO and send them to the user. So we're going to have to overwrite some of these functions from the vault. I definitely, there's like a bunch of resources in the Notion document on ERC 4626. So you don't have to, like, we're not going to cover like exactly every function and how it works, but there are some things that we definitely need to know that we want to override. So the deposit and the withdraw, like the deposit function and the withdraw function, we definitely want to override those. The total assets, we definitely want to override those as well, because, like, as you can see, currently this is pointing to this contract and we want to point it to the DAO's contract. So let's get some stubs in here. Yeah, so this is the functions that we're going to override. We're not implementing them yet. We're just putting this here to silence these warnings. Withdraw, and then there's also another function that we want to implement as well, withdraw from DAO. So we need to, this plugin has got to withdraw funds from the DAO and send them to the user, essentially. There's also something else that we want to do as well. Maybe the DAO might want to pause deposits or pause withdrawals, right, from the vault for some specific reason. So we also need to implement that logic as well. Okay, so first of all, like, let's start with that pausing logic. So as you saw from last time, this pause permission ID is just a keccak 256 hash. And this is the role that another address or account will need to to pause this contract, right? Again, later in the setup contract, we're going to see how you assign those permissions to different accounts. But yeah, we're going to need a pause permission. So we also need the actual flag itself. And we're going to have an event here and throw an error if someone's trying to use the contract when it should be paused, essentially. And then there's also this toggle pause permission here. And it's pretty simple. It has this auth modifier saying that you need to have this permission ID to toggle this. And yeah, if it does get toggled, it just flips it and emits a toggle paused. I'm actually going to move this to underneath this initialize function. But yeah, so that's pretty much it from the plugin side. Now we're just going to override these functions here, essentially. So total assets. Going to, so we're just using it exactly as it is in the underlying contracts, but instead of the balance of this address, it's going to be balance of DAO. And we've got access to this because we're implementing this plugin UUPS upgradable. So let's also import this from the Vault contract itself. Okay, and now deposits. So this deposit function is pretty much exactly the same as the function that we've overwritten, except we're going to check if the contract is paused first. And if it is, we're going to revert. And also, instead of depositing into this contract, we're depositing into the DAO's address, right? So if we look in the underlying underscore deposit, find it, it's going to look pretty similar, right? Fantastic. I also need to get safe ERC 20 from the Vault contract. I mean, you could import this directly from OpenZeppelin from where it is, but seeing as we're relying on this Vault contract, we might as well just import it from there. And finally, the withdraw function. Yeah, and yeah, so that's it. So, it does exactly the same thing as the underlying withdraw function. It burns the Vault's tokens when a user is trying to withdraw from the Vault. It emits the withdraw event. The only difference is we have this custom withdraw from DAO function because obviously it needs to have there's a special way to do this from the DAO. So let's do that. Okay. All right, cool. So we kind of get to the meat of things. Then how exactly does this plugin tell, or any plugin for that matter, tell the DAO to do something specific, right? So this plugin is going to tell the DAO to transfer some funds. And the way we do that is we have an array of actions that we tell the DAO to call. In this case, we're only doing one action. We're telling the DAO to call the asset contract. The value is 0 because it's the amount of ether that we're sending to it. And we're just going to encode the function call that we want the DAO to do, right? So we want the DAO to transfer 2 assets, right? So this is the 2 address that we're sending the tokens to, and the assets is the amount of assets we're sending, right? One thing that we're using, you could use ABI encode call. There's other ABI encoding methods you can use, but encode call is actually preferable because you get some type safety here. In the execute function, we passing in those actions. This allow failure map means that are any of these actions allowed to fail without the whole transaction reverting? You can kind of think of if you was swapping some tokens or some NFTs on a OpenSea or something like that, and you had 5 tokens that you were trying to buy, and one of them had already been sold. If you don't mind some of those actions failing, then you could create this bitmap. But 0 just means all of the actions they have to pass, otherwise revert the whole transaction. And the only other thing, we have this call ID. This is kind of like, this could be anything you want it to be, but it's kind of like a nonce to like tell the DAO that, yes, we executed this thing, and like there's a unique number associated with it. If we was just to have like the 2 and the assets, then this wouldn't really be a unique number, because, you know, if someone else tried to withdraw the same amount to the same account, then they would have the same call ID. So we're also using this nonce as well here. So I kind of have to add that nonce back in because we don't have it here. Go back up to the top. So now we have a nonce. And everything looks like it's working. Also as well, if I just to show you like this encode call, but if we added another variable here like 3, it's going to say, yeah, well, that's not correct because because we're using encode call essentially. If we was using ABI encode pack, then we wouldn't get that IntelliSense at all. So we're pretty much done here with the Vault plugin itself. One thing that I would like to do is I'd probably like to, even though this gets initialized to false automatically, I still would like to do that specifically. And that's pretty much it for the plugin contract. I'm going to have a look, see are there any comments, are there any questions. I can pause for now. Okay, cool. Again, I know I'm moving pretty quickly, but yeah, there's a Notion document, and you know, you can jump into the BRB inside Aragon or inside the BRB server, and if you have any questions. Okay, so let's move on to the second part, is the setup contract. So the setup contract, we need, give me 1 second. Okay, so let's create a new file called Vault plugin setup. I'm just going to paste some boilerplate code here. It's pretty much similar to my plugin setup, except I've stripped some stuff out of it. And there's 2 main functions that we want to implement here. We want to prepare install and prepare uninstall. So just to recap, the setup contract is like an install script for your plugin. When you try to install your plugin into a DAO, this contract is going to be responsible for deploying that plugin, for configuring the permissions that the plugin needs on the DAO, and for configuring plugins permissions that other addresses might need on this plugin. Right? So the first thing we're going to do is we're going to decode the installation data. So every single plugin will have different installation data. It will have different arguments that need to be passed in. And the way we handle this is we just encode whatever your parameters are, you ABI encode them and you decode them inside the plugin. So I'll show you what that kind of means now. So let's first do the decode action. Okay, so yeah. So if we go back to our Vault plugin, there's only one thing that we need to pass in, which is the asset essentially, right? So this is essentially an address. So we're going to encode this asset address, and it will be that data essentially, right? So so all we need to do here is just ABI decode the asset. We don't need to do that for the DAO because the DAO address is passed in as a parameter. So now we need to deploy the plugin second. Because this is an upgradable plugin also, we need to use a special function to deploy it as a proxy. There's an implementation for this. Like, so when you deploy the setup, there's like one implementation contract that all other proxies link to. And yeah, I'm also going to import in code call. In fact, let me just copy this whole thing over here actually, put it in here, and then get rid of some of these other bits. Okay, so that's the deploying the plugin. And then the permissions. So let's do that. So we need 2 permissions here, right? I'm just going to actually copy them in right now also. So 2 permissions need to be set up here. Number 1, the DAO needs to have execute, the plugin needs to have execute permission on the DAO. Because if we go here, back to our thing, we see that inside our plugin, we're calling execute on the DAO. And this is obviously is a very sensitive plugin. This means like, essentially, if anyone has this execute permission on the DAO, you can tell the DAO to do anything, to drain all of its tokens, to call any contract or whatever, right? So obviously it's a sensitive permission, and this plugin needs to be assigned that permission essentially, right? So what we're saying here is for permission 0, the operation is to grant. So we want to grant this permission where it's on the DAO, who, the plugin, and the permission ID is that execute permission. In a more realistic scenario as well, like because execute is such a broad condition as well, like it can execute anything, right? We may want to create a custom permission condition to say, okay, then, well, yes, the plugin can execute, but it can only execute under these conditions. But with time constraints, we're not actually going to do this right now. But just know that this is definitely something you can do. You can further restrict permissions, and this introduced like a whole nother layer on top of this permissions architecture, essentially. But that's probably for another workshop. And then the other permission that we need to assign is the pause permission. So we're going to grant this permission where it's on the plugin this time. Who? Only the DAO, right? So the DAO is going to have pause permission on the plugin. So if the DAO so deems to, they want to stop accepting funds for whatever reason, the DAO can call pause essentially. And like you can kind of see how these things work together as well. So how exactly is the DAO going to do that? Well, it will have like a another governance plugin, maybe a multi-sig, maybe a token voting plugin, and that plugin will have execute permission on the DAO, and then it could like execute this action essentially. So, and finally, we're going to just return this permission. So that's the prepare installation function done. And then we also have like the uninstall as well. So what happens if we want to uninstall this plugin from the DAO? So we pretty much do the opposite, which is here. So we're going to do the opposite essentially. So we're going to say, if we want to uninstall this, we no longer want this plugin to have execute permission on the DAO. So the operation is going to be revoke, where on the DAO, who, the plugin contracts. Again, there is no condition attached to this at the moment, and it's the execute permission ID. And also just for fullness sake, we're also going to remove the pause permission from the plugin from the DAO, essentially. There's one other thing, like before I move off of this, there's one thing that I like to do, like I've been doing recently as well, is that like this ABI encoding and decoding, like when you have a lot of parameters, it can get a bit cumbersome, especially when you're doing it from TypeScript or JavaScript. So I generally like to include a like a view function to do this encoding from the setup contract, but we don't have time to do that today. So maybe in a future version we'll cover that. Okay, so that's the end of like the setup. Yeah, is there any questions so far? Okay, awesome. Let's move on to the tests, right? So this is like using Foundry. This is, I guess, for me, the best part of using Foundry is the unit testing. It's surprisingly straightforward to use unit testing in Foundry. I think it's because it's really close to, you're just using Solidity, right? So you're just importing Solidity contracts and directly using them. Whereas if we was doing this in Hard Hat, the boilerplate just to get some really basic tests set up would be quite annoying, right? So yeah, so the way that this works is you have an abstract contract. This is like setting up the tests. We have the DAO here, we have the plugin setup, and some other stuff that you need for your plugin. And the setup function, it's just, you're just going to deploy the setup contract, the one that we just built. We're going to encode that data that you need to deploy your plugin in the first place. This test suite has got some helper functions. So create mock DAO with plugins. So essentially, you know, you're just going to just pass the setup contract in and the setup data that you just done here, and it's going to give you back a DAO and a plugin, right? And then how you use this is you create a new contract for each describe block. If you was thinking about this in JavaScripty sort of ways, yeah, you have one contract that does like one thing. Yeah, so here we're doing the initialization test. So we're going to set up the contracts. We're going to make sure that the DAO that is in the plugin is the one that was deployed, and just assert that that number was set. This is, you know, in the boilerplate test. And of course, you shouldn't be able to reinitialize this as well. So ETE tests are pretty cool. This is going to like fork the network that you want to fork and do all of the stuff in a more realistic way. We don't have time to do this today, so we're not going to do ETE tests. But you should definitely have a look through the base classes to see like how stuff is happening under the hood, how like we're creating that mock DAO, and you know, we've just got some other handy functions here, time travel, block travel, you know, some basic stuff here. Okay. So what we want to now do is we want to implement our own tests. So we're going to delete these. And now we've deleted those as well, we can delete these other boilerplate functions as well. Okay, also as well, one thing that I forgot about as well is in the tests, we also need a mock token. So this is just basically a mock token. We need one for the deposit token for our unit test, essentially. So it's just got an open mint function, pretty straightforward. And then we're going to add a vault plugin .t.sol. So the convention is to add .t.sol to your Foundry tests. And yeah, so what have we got here? We have like our abstract plugin test, like the first one that we saw. Here we just have the same things. We have the DAO, but now we have our Vault plugin, our Vault plugin setup, our mock token, which is DAI. This is going to be like the deposit token for our plugin. So now we're setting up the Vault plugin. We are deploying the DAI token. We are setting up we're encoding that setup data with the DAI token, and we're going to like call this function that's going to give us a plugin and a DAO, and we're off to the races. Actually, what I probably should have done a while ago, this is to make sure that this stuff's even compiling. Forge build. Ah, great, fantastic. Okay, so everything's building, everything's working. Let's go and add our first batch of tests. So this is just another contract. It's going to call, it's based off this other base abstract contract. And yeah, we're going to test that it's initialized correctly. So the address of the plugin, the DAO and the plugin should be addressed the same address as the DAO that we deployed. And the assets, the base assets in the plugin should also be the DAI asset. And also, you shouldn't be able to reinitialize this as well, right? So this should fail if it reinitializes. So let's try to run that. Forge test. Oh, whoops. Okay, we see that those passed. Also as well, you can get like stack traces as well with this. So you can like, this is another really cool feature of using Foundry, is that you get stack traces, and it's way easier to debug when you can see exactly where in the contracts have been called, essentially. So now let's do our final set of tests. Of course, as well, just it should go without saying that these are obviously not exhaustive tests here. Like all we're doing here is we're just going to test that it initializes and that the plugin is live. Like you can pause and unpause this this plugin. Definitely would want to test out some of that deposit and withdrawing logic also, but this is just to get you set up. Yeah, so it sets up. We're going to test the pause. Only the DAO it has this permission to pause. So we're going to prank the DAO, meaning that the next call is coming from the DAO. And now we should assert that the plugin is paused itself. And the last test is that it should revert if someone's not authorized, right? So we're not pranking the DAO now, we're just calling the pause plugin. And the error that you get back is a custom error. So this is how you test for that. So let's clear, and let's run those tests again. And yeah, those are also working. Great. So I'm going to take a pause there because we've covered quite a lot. Are there any questions so far? No? All right, great. So what have we got left to do? So we've deployed, we've built the plugin, we've built a setup contract, we've run some unit tests. Now, what do we need to do now? We need to like deploy this on chain, right? So we want to like deploy our stuff. So what we're going to do is, now we're back into JavaScript land. Let's clear the screen and let's install some stuff. In fact, we're not going to install all this stuff, first of all. Let's actually get rid of most of this. we're just going to install the Aragon CLI. So we're installing, you can install this globally if you want to, but I prefer to install it in the plugin, in the project, you know, because updates is just easier to update and stuff like that. So what the Aragon CLI does, it enables you to deploy your plugin setup contracts, your repos, find information about plugins, and it's essentially like a dev tool to help you deploy Aragon plugins. PNPM, Aragon, oops. Okay. When you run this for the first time, you might see some errors here because you haven't got a private key set up and Tenderly. That's another thing that's really handy with this. It integrates with Tenderly really well. So if there are any errors at any stage during your life cycle, it gives you a Tenderly link and sends you Tenderly to show you like a nice stack trace, you know, similar to what you get with testing, but a bit more in depth. So as you would use this for the first time, is you would use npm Aragon, you go settings, like you can set your private key here, you can set your Tenderly key here, and your settings. I've already got this installed, so I'm just gonna do view. So you can see that I've got Tenderly enabled. It shows me what wallet that I've got set up. It shows some information about like what funds I've got on what networks and how many transactions I've sent on those networks. And there we go. Yeah. So what do we want to do? First of all, we want to like deploy our setup contract. So PNPM, Aragon, deploy. In fact, I'm just going to run this with the help flag first. So you can, there are two ways of using this. You can like pass all the parameters that you want to the deploy function or deploy command, or you can just run deploy and get like an interactive mode essentially. So we are going to deploy our setup contract. So it's a Vault plugin setup. We're gonna use Gorelli, why not? Simulate, yes we do. So actually I realize I'm not gonna be able to show you this because I don't have this set up already, but you get a link to your simulation here. You get a link to your simulation and like if there's anything wrong with it, then, you know, but I'm just gonna deploy. Another thing that this is really good for is that sometimes like the errors are not very intuitive. Sometimes you might try to send a transaction on chain and you just get like a failing deployment or failing, you know, there's gas exceeded limit and you have no idea why the transaction's failing. Tenderly helps out with that, but also as well, the inputs are validated, right? So if you put in addresses or something like that and it's just not quite right, it's just not going to work. I also realized as well something that we've forgotten to do before we actually deploy our plugin. There's also metadata associated with these plugins, right? So on chain, we can set the names of the stuff. So we're going to call this BRB Vault. BRB Vault plugin. And then there's also like this build metadata, and this essentially like tells other users what parameters you require for installing into your this into a DAO. So we need an address, right? So we're going to change this from U256 to address, base assets, base token we can use, and this is for the vault. Okay, save those two things. save that, close that, close that. All right, now back here. So, okay, so we have our setup contract deployed. And now we want to like deploy that on-chain repository, right? So we want, let's have a look at the commands we have. Deploy, so now we want to publish a plugin repo. So we go publish. What is the contract address? And we have it here. The subdomain we're going to use is BRB-vault-420-12. This can't have any capital letters or dots or anything. If you do, it's just not going to let you do it, right? So like it's not super intuitive to do that if you're doing that from the using it from a script or something. So this build metadata, so let's find this build metadata and then the release metadata. There it is. We're using this on Gorelli. The maintainer address is just like your own address. This is the address of the account that is authorized to upgrade this repo. Again, you can simulate this. I'm not going to because I'm sure that this works. Famous last words. Yes, I do want to publish this plugin. It's going to upload that metadata, the build and the release metadata, and I should get back this on-chain repo. So whilst we're waiting for that to happen, just go check if there are any questions. No? Okay, cool. So we have our Vault deployed here. This is fantastic. We have it deployed. We've run some tests. How do we install this into a DAO? How do we deploy a new DAO with this, right? Right now, this still requires us to write some scripts. In the future, the Aragon CLI will be able to do this step for you as well. However, for now, we have to use the SDK. And that's what those other things that we were installing were. So to write a script, the Aragon SDK is still using Ethers version 5, so we need that. We already have that installed. So the SDK client, .env, so we can protect our private keys and whatnot. So let's install that stuff. Inside this env file, you want to create your own env from this. So you want to copy this env example into env. I'm not going to open mine now because I have a private key in there. You definitely want to like just add your Infura key, and you should be ready to go. Okay, so I'm going to copy a bit of boilerplate, and we're going to create a new folder called scripts. Leave this out here and deploy .ts. Okay. So there's just a bunch of stuff here. Like we're importing some stuff from the SDK. There's actually quite a bit going on here. I'm gonna still just power through this really quickly, but the script's gonna be here, and any questions about this afterwards, I can do a deep dive into like using the SDK essentially. But what's the goal here? We want to deploy a DAO. We want to deploy our Vault plugin in there, and we also want to deploy a governance plugin, so we can update permissions and stuff like that. We're going to use the multi-sig, and we're going to deploy our DAO. So we need a name for our DAO, so we're going to call this whatever that is. We're deploying on the Gorelli network. This is the multi-sig permissions. We're only requiring one approver and one account. The vault permissions, the repo address that we just deployed. We need that. Yeah. We have an address for DAI for the DAI token. This is one that I deployed earlier. And for the SDK, we need some stuff to set it up, right? So we're going to need a private key, which I've got in my env file. And we also need an Infura endpoint, which I also have in my env file. And we create this client. Just to make sure that this works, let's call this working. Okay, and then let's clear all this. And how we get the npx scripts deploy. Okay, so it's working. Great, fantastic. Okay, so what next? We want to get the parameters to install the multi-sig plugin, essentially, right? Hold on, that's a bit too much. So you can go and check into the types here, like what all this does, but we're just setting up the initial parameters here for the multi-sig plugin, like the minimum approvals, which we set up, there was already one. The members is just an array of one address. And this is like the install item, which you're going to see in a moment. When we actually deploy the DAO, we need this install item. This is basically going to install this multi-sig plugin with those parameters into our DAO. That's using some stuff from the SDK. For our own plugin that we just built, we have to kind of encode that stuff in a custom way. So, oops. So what's happening here is we're ABI encoding that address, right? Right now, it's only one address and like one type, so it's pretty easy to understand. This can be a bit more complicated, hence why, like I was mentioning earlier, in the setup contract, it's a better practice to include an encoder, so it's easy to like get those parameters encoded. But for now, all you need to know is that we've created this encoding parameters, and this is the repo address, and this is essentially going to give us the install item for our Vault plugin. So those are the two plugins configured to install into the DAO. What else do we need? We need to get some metadata for the DAO itself. So this is like stored in IPFS, the name of the DAO, the description, its avatar, any links it needs, and then like we put it all together. So you have the metadata that's pinned here using the client. This is going to be the name of your DAO, right? So right now it's BRB test 4206917, and these are the two plugins that we want to install into the DAO. So like that's pretty much it, ready to go. Like it's all configured now. We just need to actually like call these transactions. So how do we do that? We use another SDK function called create DAO, surprisingly. Let me get that here. Yeah, so here we are. So on the client, we're going to call create DAO. We get like an async iterator. It's like two different promises. So we have this step, so it's two different steps. So on the first step, we're just gonna call the transaction to deploy this DAO with the plugins. And then the second one, once that's been mined, it's gonna give us back the address of our DAO and the address of the repos, essentially, right? And it's also gonna console log a link to the DAO that we're just gonna create. So let's run that script again. And okay, cool. So we're still waiting for it to be mined. And there it is. It's mined with, so this is the DAO's address. These are the addresses of the two plugins in the same order that we deployed them. And that's it. Speed run's finished. I went through that really quickly. Again, this should be on YouTube, and they will be a Notion document and a GitHub repo. And any questions, we can take them now. And I'll also be available in Discord. Thank you, Samuel. Thank you. Okay, you're Spanish. I love the Spanish accent. Just reading through the comments. Great. So any other questions?
Yeah, guys. So first of all, thank you, Aaron, for this amazing session we had. Also, is there any questions? Please put up to Aaron so that you guys have a clear vision towards today's session. And don't miss the bounties and the prize today. So buckle up, and you have a chance to win amazing prize and swags and bounties as well. So yeah, let's wait for some seconds so that if there is any doubts or questions, can put up in the comment section. Also, you had a chance to win a fully sponsored trip to India. So this is all you guys are getting. So just buckle up. So
Nice.
yeah, and I think there is no doubt, so we can end the session. Also, we are
Awesome.
always here on the Discord for helping you guys. We are hanging out there, so please, if there is any doubt, and you can post it on Discord community. So yeah, thank you, Aaron.
Thank you, guys. Highly appreciated.
Yeah. So yeah, bye guys. Tada.